Alright, so here we're going to be graphing using transformations. So we're going to be graphing the quadratic function, which the graph of the quadratic function is called a parabola. So you could have two types of parabolas. You could have some that are going up, so this is opens upwards, and then you could have some that are facing down, so then they open down. And something special about these is the very top or the bottom, that would be called our vertex. And then straight down that point is an axis of symmetry. So we're going to say AOS, usually for shortcut, we say AOS. Alright, so this is what they would look like, and we're going to just go ahead and start graphing. So example number 1 says graph f of x is equal to x squared and g of x is equal to x squared plus 1 on the same axis. Alright, so we're going to start off by making a table. And notice that, you could replace f of x with y. So let's just do -2, -1, 0, and 1 and 2. So -2 squared, you got to put parentheses around it. So that would be 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Alright, so I'm going to go ahead and graph that. Okay, so that was the first one, and then we're going to go ahead and make a table for the next one. So -2 squared plus 2, that's going to give you 4 plus 2, which is 6. -1 squared plus 2, so that's going to be 1 plus 2, which is 3. 0 squared plus 2, that's just going to be 2. 1 squared plus 2, that's going to be 3. 2 squared plus 2, that's going to be 4 plus 2, so that's 6. So let's just take a look what happened with these y values and then these ones. The difference between them is you add 2. So you add 2 to 4 to get 6, you add a 1. You add 2 to 1 to get 3, and etc., etc. Alright, so let's go ahead and graph the green one. So we have -2, 6, so that's above where we're at, so we're just not going to graph that one. -1, 3. 0, 2. And 1, 3. And then the other one would be up there, so we're just going to estimate it. So that would be this one. So remember, the blue one is our parent function. So what happened from the parent function to the green one? It went up 2 units. Alright, and then it also says to state the domain and range. So I'm going to go ahead and do the domain of the original, so of the parent function. So domain, remember that's your x values, so it's technically going forever on the left side and the right side. So it's going to be from -infinity to infinity. And then your range, well, it starts here. The y values start here, and then it goes all the way to infinity. So it's from 0, including 0, to infinity. Alright, so now let's do the domain and range of the g of x, so same thing, domain is always going to be from negative infinity to infinity for a parabola. And then your range is where your y values start at. So in this case, it's here. So it's from 2 to infinity. All right, so generalizing what we just did right now is graphing the parabola of f of x, x squared plus k. So if you have that plus k on the outside, so plus a number, if that number is positive, then it's going to move k units up. And then if that number is negative, it'll move k units down. So let's go ahead and do a couple examples of that. So here we have example 2. We're going to go ahead and graph this, and the first one is x squared plus 1, and then the second one is x squared minus 3. So we always want to start off with our parent function. I have the parent function pretty much memorized, but if you need to scroll up and look at what your parent function is, you can. Alright, and then so this first one, it says x squared plus 1, so since it's a positive and it's on the outside, this means 1 unit up from the parent function. So that blue is the parent function. We're going to go ahead and move all these points up 1. And then we'll connect those dots, and that's the graph. So kind of like what we learned with the absolute values and the radical graphs. Alright, the next one, I'll go ahead and graph that in orange. That's 3 units down from the parent function. So you take each one of those points and you're going to move them 3 down. So here, here, and there. Alright, there it is, and we stated the transformations. Alright, the next transformation that you could have is something where you move it to the left and right. So notice this is now on the inside of the square, and so it's x minus h squared. Is positive, the graph moves left h units, so even though it's positive, it is going to move to the left. And if h is negative, the graph moves to the right h units from the parent function. So let's go ahead and try that out. And I'm going to go ahead and place a graph. Alright, so I went ahead and graphed the parent function. So we'll go ahead and do this one first. So we have x minus 3 squared. So what that means is we're going to move 3 and either to the left or the right. So you would think it would move left, but it actually is going to move right. And again, that's because when it's inside the parentheses or inside the function, it does the opposite of what you think. And then this one over here, which we'll graph in green, it's actually going to move left 1 unit. Alright, so let's go ahead and graph it. So we're going to move everything 3 units right. So 3 units right. And we'll connect those dots. Alright, perfect. And then we're going to go ahead and move the other one 1 unit left. That wasn't perfect, but that's fine. Okay, so that's what the graphs would be. And then let's go ahead and do the domain and range. So remember, the domain for a parabola is always positive or negative infinity to positive infinity. And then if you see the y values for all of these start at 0. So it's still going to be from 0 to infinity. And then over here, the range and the domain will be the same. All right, so moving on to the next one, we have one where we have a double transformation. So I'm going to go ahead and graph the parent function again. And then we could talk about what this does on the outside. So we'll do that in orange. So that moves 3 units down. And then this one right here is going to move 1 unit left, right? Because remember, it does opposite when it's on the inside. So that means each one of those points from the parent function, you're going to move 3 units down and left 1. So 3 units down and left 1. And each one of those. So 3 units down, left 1, 3 units down, left 1. All right, and that would be our function. So again, our domain, we're just going to go ahead and quickly do that, is negative infinity to positive infinity, and then our range, the y values start at negative 3. So I don't know if you noticed the pattern with the range, but this is always our k. So the formula for this is k comma infinity. All right, moving on to the last one. We have graphing the parabola where we have y equals ax squared. And then we have 3 that we're going to go ahead and graph, and we're going to go ahead and use a table. All right, so I went ahead and graphed or did the table for the parent function, which is y equals x squared here. And then what you're going to notice is here you have x squared times 3. So we already did x squared. That means all we have to do is multiply the values times 3. So 4 times 3, that's going to be 12. 1 times 3, that's going to be 3. 0 times 3, 0. 1 times 3, 3. And 12. And then over here for this one, we have to multiply those values by 1/2. So 4 times 1/2, that's 2. 1 times 1/2 is 1/2. 0 times 1/2 is 0. And same thing, 1/2 and 2. So now we could go ahead and graph those. So I'm going to go ahead and graph the parent function. Alright, so I went ahead and graphed the parent function, and then I'm going to try to graph as much of these points as possible. 12 is definitely going to be outside of the graph. So the next one is the green one. So we have 0, 0, so we still have 0, 0. And then we have 1, 3, and negative 1, 3. And so that would be our graph. And then the orange one is going to be still 0, 0. And then 3, 1/2. Sorry, 1, 1/2. And negative 1, 1/2. And then we have 2, 2. And negative 2, 2. All right, so that's our graph. So if you notice, 1/2, if you multiply something that's smaller than 1, it's going to make it wider. And then if you multiply something that's greater than 1, it's going to make it skinnier or narrow. So, and we multiplied each one of these y values by that number. So if I take 1 and I multiply it by 1/2, it gets you 1/2.